All right, long division. I hated long division when I was a kid. Something about it I just didn't like. But just because I hated it didn't mean that it wasn't important to learn. Again, it doesn't mean that I didn't learn it. I did learn it, okay? But I struggled with it a little bit. I had to do some extra work. I remember going to my dad and him showing me, and he was a teacher as well, but he kind of got ticked off at me because I was kind of dumb and I couldn't figure it out. And he's like, "It's right there in front of you." He started yelling at it. It's a miracle that I became a teacher. Now, my dad was all right with stuff like that, but I mean, he was a teacher, so he was busy, having his headaches with the kids at school, and his last thing he wanted to do was come home and work with me. You know what I mean? I get it, because I got kids that are the same way. But anyway, that's my story about long division. But we're going to do division of polynomials. We've actually done division of polynomials already, okay, kind of, with at least monomials. I'll give you a quick example. I don't have this in my notes, but I'm just thinking this off the top of my head. So what if I had 12x cubed y squared over 3x to the 5th y to the 4th. Okay, just making these up. This is actually a division problem, and it's of polynomials, right? This is a monomial, this is a monomial, right? So we're dividing two monomials. So we've done that before. What we're doing today is quite a bit different, all right? But I'm just showing you an example that we have divided polynomials before. How would you do this? Well, 3 divides into 12 how many times? 4. Now look at this. I got 3 x's here, I got 5 x's here. So 3 of these cancels with 3 of these. How many do I have left? I have 2, so that's an x squared on the bottom. All right, what do I have here? I got an x squared or a y squared on the top, a y to the 4th on the bottom. These 2 y's will cancel with 2 of these y's. How many do I have left? I got 2 of them, so let's write it real nice and pretty. I got a 4 on the top, everything else canceled on the top, over, what's here? X squared and y squared. So that's one example of dividing polynomials, all right? We did it earlier on. It's a little bit easier. But today what we're going to do is we're not just going to divide by monomials. What we're doing is a little bit more involved. Let's go back to, I don't know what grade. Anybody know what grade you first learned how to divide fractions? Not divide fractions, but divide, like long division. 3rd grade maybe? 4th grade? 8th grade? Oh, he said 8th grade? Probably 4th grade-ish. Would you agree? Somewhere around there they taught you long division. Okay? So, let's start off with a little bit of an easy one, and then what if I said, what's 7 divided by 8? Because that is a division. Like Mr. Hammer, that looks like a fraction to me. But a fraction is division, all right? So 7 divided by 8. So I could write it 7 divided by 8. Or if you do it as a long division, what we're going to do is we're going to change this to a decimal, okay? All right, so if I want to change that to a decimal, which one goes on here? It's 7 divided by 8. Which one goes inside the box? I always call it the box. Which one? I hear an 8, I hear a 7. Why 7? Do you remember why? It's being divided by 8. So this is the one that you're dividing by. Here's a little trick that I learned. I forget who taught it to me. Some teacher somewhere at some point taught me this. Watch. This is on the top, correct? This is the box. So the top goes in the box. Box top. You ever hear of box tops? Used to be back in the day when I was a kid. We got cereal, right? We got cereal boxes, and then you could get a really good deal on something, but you had to submit 4 box tops, right, to your cereal, and then you get this 50% off or 90% off or something like that. That's a box top. You know what box top, right? Okay. So I always remember, I still to this day think, which one goes in here? The top goes in the box top. Can you remember that? Yeah, that's pretty easy to remember. So which one goes in here? The 7. So obviously the what? The 8 goes out here. You with me? All right, let's let's do this division. Again, this is a throwback to something you probably have not done in quite a while. I got to check to see what time we get out of here. 50. Wow. Wednesday's a late lunch, isn't it? Eat at 1 o'clock. All right, so what do we do? Anybody remember what we would do if we were going to divide this? Yeah, and what do you need to put here first? Put a decimal, good. And then stick a 0 in here, all right? We may need a couple zeros. We will in a second, yep. But you're going to put it right here first, okay, because it's 7.0 is 7. But you're right, you take that decimal and you put it right up here. And now what we do is this. We say, how many times does 8 go into 7? None at all, right? So you could put a 0 there if you wanted to. But how many times does 8 divide into 70? It doesn't go even. 8. So 8 times 8 is 64. Does 9 times? No, because that would be more than 70. It's 72, wouldn't it? Right. So 8. Everybody see that? I'm not here to teach you how to do long division from scratch. We're just trying to refresh your memory a little bit, all right? So 8 times 8 is what? 64. What do I do with that 64? And subtract. That's right. Put it under here and subtract. The reason I'm doing this is because when we do division of polynomials, we're going to follow the same basic steps. So I'm going back to 4th grade. We're trying to remember what we do here, okay? And we're going to basically copy the same steps is what we did here. That's why I'm going back to something like this. Now, what do? We subtract. 70 minus 64 is what? 6. Now, what do? Bring down the next number. The next number is a 0, so we bring that down, put it right here. So now we ask ourselves, how many times does 8 divide into 60? 8 times 7 is 56. 8 times 8 is 64, so 8 times 7. Everybody with me? So where do I put that 7? Yep, right up top here next to the 8. Now I multiply and then I subtract. 8 times 7 is 56, but I subtract it from that 60. Is this coming back to you? 60 minus 56. It's 4. Now what do? Bring down another 0. Put it right here. Well, it's helpful. If you just want to stick a 0 here, stick a 0 here, it's fine. But I just think it's helpful to remember to bring it down. Like, you don't have to write those lines down. I'm just doing it so we can visually understand what's going on. I think it's helpful, though, to put those up here, okay? And for something we're going to do on the second polynomial example, it's going to be important that you replace something with a 0, all right? So I think it's important. Now, let's do it again. So let's take 8. 8 divides into 40. Does that go even? Yeah. 40 divided by 8. What's 40 divided by 8? It's 5, right there. So 8 times 5 is 40. We subtract. Now, as soon as we get a 0, we're done, aren't we? Sometimes that number will keep on going and going and going, right? Or it might repeat and it doesn't stop. But if it's a fraction, it either stops or it repeats, okay, if you do a fraction like this. And that's your answer right there, 0.875. There's no remainder, right? That's your 0. That's your remainder, okay? Let's do another one like that.
High school students who are attending Bible in the sanctuary during lunch, please pick up your lunch and then head over to the sanctuary. Thank you.
All right, watch this one. This one's kind of same thing. This is not polynomials. This is just regular numbers again. Again, we're just reviewing long division. Again, something that should have been, it's not always, but it should have been taught 3rd, 4th grade-ish. All right? I don't know. I should ask the elementary teachers when they teach this, because every time I teach this thing, I always say, when did you take it? Nobody remembers. You guys should remember way more than I do, because it was a lot longer ago for me than it was for you guys. Anyway, I should ask them. So here's what we're going to do. We're going to divide this. 8, what is it? 42 So 842 divided by 15. Now you could write it like that, or you could write it 842 over 15, right? Or what we're going to do is we're going to get a decimal out of it, okay, or some kind of number out of it, maybe a fraction. And what goes in the box? The 842 goes in the box, because that's the top, right? And then the 15 goes out here. Now 15 is a little bit tougher than 8, right? Because we don't know our 15 tables very well, but there's a few of them that we probably know. And I'll help you out a little bit. So 15 divides into 84. Anybody, any idea? What's 15 times 2? 30. 15 times 3? 45. Okay, times 4, 60. Times 5, times 8, 90, right? Is, which one are we going to use then? 5, okay? So we're going to put the 5 right there. I could put a decimal, but I'm going to show you how we're going to write this answer in a second. Now, what did we say 15 times 5 was? 75. What do I do with that 75? I subtract. That's a key right there. That subtraction, that's something that we're going to do. All right, so you put a subtraction. Now we actually do the subtraction. 84 minus 75, that's 9. Now we don't have to bring in a 0 down because I got this other number here, don't I? All right, so I got this 2. So what do I do with that 2? I bring that down. Now, does 15 divide into 92? It doesn't go evenly, but it goes 6 times. All right, and what's 15 times 6? That's 90, right? We went through those a second ago. So I subtract a 90 from each other. 92 minus 90 is 2. Now, I could sit there and put zeros, bring down the zeros until I get a final decimal, until it starts repeating or until it stops. I could do that. But watch what I'm going to do. I'm going to leave it basically just like this. So what do I call that 2? 15 does not go into 2, does it? Okay, this is our remainder. Do you remember how we write the remainder? You could write it a couple ways. You could put R, you could put R2. You remember doing that? Here's a better way to do this though. Instead of writing the R, what we're going to do, that's our remainder, so we are going to write 2 over whatever we're dividing by. What are we dividing by? 15. And that's how we would write that answer. And that looks a little bit more like what we're going to do with polynomials. Okay? Say that again? Well, if it's at a fraction, it's not a decimal now. Okay? So the nice thing about writing it as a fraction is that you don't have to worry about repeating and putting a decimal there. All right? Let me just check my calculator real quick. Let me see what that would be. 842 divided by 15. So it would go 56, 2 over 15 is 0.133 repeating. Okay, the 3 keeps repeating. But I don't want to really write it as a decimal. Just want to write it as a fraction. Because what we're going to do with these polynomials, we're not going to use decimals at all. Okay, we're going to write the remainder as a fraction. So what do you do with that remainder? You take this and put it over top of whatever you're dividing by. Everybody with me? Okay. All right, now, everybody ready? Got your seatbelt on, buckled in, ready to go? All right. Tell you what, let's take this. I'm going to take this. And I'm going to put it right here, just off to the side, just so we have a reference. Okay? Let's get rid of this. We don't need that. We don't need that. We don't need that circled. We'll just do that. Okay. So watch what we're going to do here. That was example 12. This is example 13. This is what I really am trying to teach you today. It's probably something You know the first time I ever saw this? I was in college. I was in Calc 2. I was in my second semester of calculus in college when I first learned about dividing polynomials. I never learned it in high school, okay? Then I got to college, professor's on a board, chalkboard, right? I remember specifically sitting there and him doing all this stuff. He's going crazy. You should see these problems in college. It was like crazy long, right? Took up the whole board. And he's like, okay, this part right here, we're going to divide polynomials. And and everybody's looking at each other. And he noticed everybody's looking at each other. He says, what? You've never done this division of and everybody's looking at each other. I've never seen this in my life, right? We're Calc 2. And we've never seen a high school, thing like this that you guys are learning right now. And he's like, oh, I can't believe you don't know how to do this. So he had to show us how to divide polynomials. I remember that's the first time I ever did this. And now you guys are in high school and you're learning it, all right? So when you get in your Calc 2 class and your professor says, he starts dividing polynomials, you go, oh yeah, that's right. Mr. Hamrick showed us how to do that, okay? All right. So anyway, I just thought that was an interesting little thing. So, and I wasn't the only one. Usually I was the only one that didn't know how to do stuff. But in that case, nobody in the class knew what that guy was doing. Dr. Wooldridge, he was a great teacher though, really good. 4x squared plus x plus 7. We're going to divide, I'm going to write it how they do it. We're going to divide this by this, x squared plus 1. That's what we're dividing by. So we're taking this and we're dividing it by this. So we want to write it with our box. Okay, it's going to be a big old box this time, all right, because we got a lot more stuff to put in here than just an 8, a 4, and a 2. All right, so make a big old box. What's going to go on the outside? We're dividing it by x squared plus 1. So what's going to go on the outside? Well, it's not an x plus 1. It's a what? X squared plus 1. Okay. What's going to go in the box? This would be on the top, right? This divided by this. So this thing goes in the box. Now, remember we talked about descending order? It's very, very, very important that you put it in descending order. And if there's any gaps, we need to fill in the gap. Now, there is no gaps on this one, but on the next example, there's going to be some gaps. What do I mean by that? This is x cubed. The next one is what? X squared, which it should be. It goes down in order, right? 3, 2, 1, 0. Okay? So that's got a 3x cubed. That's got an x squared. That's an x to the first. And that technically is an x to the 0, right? X to the 0 is 1. So are there any gaps? No. On the next one, there's going to be some gaps, all right? So I don't think we're going to have enough time to do this, but we can probably finish this up tomorrow, which is fine. But at least I wanted you prepared for what we're going to do. All right? What did I say? 50, right? Is that when you get out of here? 50? Okay, so I only got less than a minute. So I'm going to keep it right there. All right, remember where we left off. Anybody taking notes on this? Okay, so that's where we're going to leave off, and we're going to try to divide that tomorrow. Okay?